Most teams don't actually have an automation problem. They have a model problem. They keep building workflows like the business still moves in neat, predictable steps, but the reality is that it doesn't. Decisions now depend on a constant stream of signals coming from apps, identities, APIs, data platforms, and people, all hitting the system at once. Your old flow design simply can't keep up with that kind of pressure. So what happens next? One flow calls another flow, then that flow calls an API, and that API writes back to a system that triggers something else entirely. Delay starts hiding inside every single one of these handoffs. It looks automated on the surface, but the system actually gets slower as it grows. What I'm going to show you today is simple. We will look at why workflow-first thinking creates automation debt, why event-first orchestration is the key to cutting decision latency, and exactly where the new Power Platform API connectors start to change the architecture. The old model is breaking. Workflows optimize steps, not time. The old model is easy to recognize because most of us are the ones who built it. Something triggers, the system runs a sequence, and then it finishes. Maybe it branches or waits for an approval along the way, but the logic is always a straight line. That model came from a world where process design meant mapping a stable path through a known set of tasks. For slower back-office work, that was usually fine. If you were just automating a document handoff or a scheduled update, the only real question was whether every step completed. But that is not the pressure most organizations are under anymore. Now you are sitting in a meeting and you need an answer immediately. A security alert fires and it cannot wait for a polling interval. A payment posts, a user gets provisioned, or an account changes state, and 5 other systems need to know about it right away. In this environment, the question isn't whether the flow eventually finished its run. The real question is how long it took the business to react to the change. And this is exactly where workflow thinking starts to crack. Workflows are built to manage individual steps, but they are not designed to compress time across a whole response chain. What typically happens is that every new exception gets added as more flow logic. You add a special branch here, a retry there, and another connector for a different system. Then someone wraps a legacy endpoint and a child flow gets added because the main one has become too large to manage. Eventually another owner appears because one team owns the trigger, another team owns the API, and someone else entirely owns the approval. The process still looks centralized on a diagram, but the actual responsibility is spread across hidden layers. That spread matters because delay compounds over time. A wrapped legacy call can still carry a multi-second delay, while a connector hit might face throttling from the provider. A queued action waits its turn in line, and every retry adds another round trip to the total time. A human approval pauses the entire chain because someone is stuck in another meeting. None of these delays look dramatic when you see them by themselves, but when you stack enough of them together, seconds become minutes. Those minutes turn into operational drag right when the business needs clarity the most. So this all clicked for me when I stopped looking at flow diagrams and started looking at decision latency. I didn't care about average runtime or whether a single run succeeded. I cared about decision latency. That is the time from the moment something happened to the moment the right action actually started. That is a very different lens to look through. It forces you to care about P95 processing time, queue waits, handoff lag, and the unclear state between systems. Averages hide the pain, but the long tail is where your real operational cost lives. And one level deeper, these giant orchestrator flows give people a false sense of control. It feels safe to put everything in one place because you can open one designer and point to a single asset. But centralizing all that cross-system logic in one master flow usually doesn't create control. It actually hides fragility. You don't get one clean source of truth. Instead, you get one crowded box full of branching, retrees, embedded rules, and connected dependencies that only make sense to the person who built it 6 months ago. So when teams say automation is getting harder to govern and slower to change, the problem isn't just the volume of work, it is the model behind it. They didn't create a clean automation layer, they built a chain reaction. Chain reactions are incredibly hard to reason about because ownership blurs and timing drifts. Every new requirement increases the chance that one hidden dependency is going to break another. Add enough of those and your automation estate stops acting like infrastructure. It starts acting like a collection of negotiated exceptions. If the workflow model is breaking under modern operational pressure, then the next question isn't how to build better megaflows. The real question is what the business logic should be designed around instead. The new model, events as the API layer for the business. The fundamental unit of design has to change. We need to stop asking what task comes next and start asking what just happened. It sounds like a small distinction, but it completely flips the architecture. A workflow starts with a planned sequence, but an event starts with a fact. Something changed, a process finished, a specific threshold was crossed. The system's only job is to expose that moment clearly so the right parts of the business can react. A business event is a named moment that actually means something to the organization. Think of labels like incident detected, user provisioned, or invoice submitted. These names matter because they describe the state of the business rather than the behavior of a tool. You aren't telling the system to run step 3 or update a specific row. You are describing a reality the company cares about, and once you define events this way, your automation stops revolving around app mechanics and starts following business reality. This is where the model really breaks away from the old way of doing things. In a workflow-first setup, one thing happens, and the system predetermines the entire route. In an event-first model, that moment is published exactly once, allowing different handlers to react in parallel. The ticketing system opens a case while Teams posts the context, and at the same time, an enrichment service adds data while a classification service scores the severity. It is the same source moment triggering different reactions without a single path trying to carry the entire burden. This approach doesn't lead to chaos. It actually creates much cleaner boundaries because every handler owns one specific response to one specific event. You get smaller logic, clearer ownership, and fewer hidden branches. If a team is responsible for escalation, they simply subscribe to the event and manage that process. You stop pretending that one central flow understands the entire business better than the specialized teams working inside it. One level deeper, this is exactly why event catalogs are so vital to the strategy. An event catalog serves as the shared language for these moments by telling the organization which events exist and what they mean. In Dataverse, these catalogs make high-value events discoverable so teams can expose custom APIs intentionally instead of burying them in private logic. It represents a massive shift because the contract and the business meaning come first, while the technical action simply follows. This shift also makes governance much easier because you are governing something explicit and visible. A cataloged event can be seen, a stable contract can be reviewed, and a small handler can be tested. You can't do that with hidden branching inside a giant, messy workflow. People often assume that distributed reactions mean losing control, but the opposite is actually true. Centralized logic tends to hide important decisions inside implementation details, while event-driven design forces you to name the event and separate responsibilities. If you remember nothing else from this, remember that workflows optimize steps, while events optimize time. That is the core shift. A workflow asks what needs to happen in order, but an event asks who needs to react right now. One is built to control a sequence, while the other is built for the speed of the response. For modern operations where multiple systems need the same signal at the same time, that difference is everything. This is also why events function as the API layer for the entire business. We usually treat APIs as technical interfaces, but business events act as enterprise interfaces for meaning. They expose the moments that matter and tell every subscriber the same thing using the same source context. It creates a much cleaner foundation for orchestration than burying your business logic inside one long-running, fragile process. Once you see that, the question isn't whether events are a nice pattern to have. The real question is how the Microsoft stack is starting to support this model in a practical, everyday way. Where the new Power Platform API connectors change the architecture, we can get concrete now because this shift only matters if the architecture actually supports it. This is where the newer Power Platform API patterns start to become important. They aren't just convenience features or a nicer way to link apps together. They are structural parts of the system. Most teams still treat connectors like basic plumbing where they pick one, authenticate it, and drop it into a flow. However, your choice of connector changes far more than just connectivity. It dictates how much logic stays hidden, how many calls get inflated, and how reusable the boundary becomes when other systems start depending on it. API-first thinking starts with a completely different assumption. You don't stuff a business decision into the workflow designer, but instead, you put the contract at the edge and keep the handler small. When you work this way, the logic is much easier to reuse because it isn't trapped inside a long sequence of unrelated conditions. The detail most people miss is how much overhead comes from these wrapper-heavy designs. Research across the Microsoft stack consistently shows that native Dataverse calls carry much less overhead than custom chains that bounce across extra wrappers. Native Dataverse API scenarios can reduce your call consumption significantly because they benefit from internal optimization and caching inside the cloud boundary. This matters because inflated call volume doesn't just waste requests, it raises your throttling risk and adds delay to every response. You see the exact same issue with Power Automate limits. Request caps and timeouts become much more painful when a design keeps multiplying unnecessary calls. Choosing a connector isn't just a technical preference, it is a matter of architectural discipline. You want fewer calls, cleaner contracts, and less hidden state. Dataverse business events are a perfect example of where this gets interesting. These events only fire after a successful completion, which is a very important boundary to maintain. It means the event represents a confirmed business fact rather than an in-flight guess. By using custom APIs, you can create your own messages for high-value moments and let subscribers react only after that fact is true. That is a much cleaner trigger model than burying logic inside a long flow and hoping every branch stays aligned. From that point, orchestration starts to open up across the entire stack. Dataverse emits the event, Power Automate handles the lightweight reactions, and external systems subscribe through APIs. As your event patterns can then take over whenever you need broader distribution or pro-code processing. The platform stops looking like a simple automation tool and starts acting like a response fabric for the whole business, but there is a line here that you need to keep sharp. You should use workflows for local task execution, like sending a notification or updating a single record. Use events and APIs for business logic that needs to move across different systems. Once the logic spans multiple domains or owners, it should no longer live inside one giant monolithic flow. There are still limits to consider, and pretending they don't exist would be sloppy architecture. Cross-environment Dataverse actions are useful for multi-environment designs, but they route through APIs and lose some of the native performance you get locally. Trigger support across environments has also required workarounds in the past, so design discipline still matters. Just because you have the ability to connect environments doesn't mean you should turn the architecture into a free-for-all. Security is another major factor. If your orchestration crosses into external systems, your connection model cannot depend on personal accounts or credentials that might be forgotten. The connector layer becomes part of your control plane, which means identity and monitoring now matter just as much as the data you are sending. The connectors change the architecture because they allow you to move away from hidden workflow logic toward explicit interfaces and smaller reactions. That is the technical shift. But architecture on its own won't fix the problem if teams keep building with the same old habits. The operating model has to change right along with it. What to endorse, what to retire. If this is the architecture, what should leaders actually back and what should they start phasing out? First, you need to endorse managed identities. Orchestration should never depend on a single person leaving the company, changing a password, or losing access to a connection that nobody else understands. If your business response layer relies on user-owned credentials, then it isn't operating as infrastructure and it's actually just a workaround. Microsoft is pushing secretless patterns like managed identity and service principal access for a reason. The response model has to survive role changes, audits, and scale, or it isn't a professional model. Next, endorse event catalogs. This isn't about documentation theater, it's about operational design. You need a small set of named moments that the business agrees actually matter. Incident detected, invoice submitted, payment posted, user provisioned. Those event names become stable contracts for the whole company. They let teams build reactions around business meaning instead of app-specific logic. Because Dataverse supports cataloging high-value custom APIs and events, you can expose those moments intentionally instead of letting every team invent its own trigger language. Then endorse observability by event. Most teams still monitor isolated flow runs, but that view is far too narrow. A green run history can still hide a bad business outcome if the signal arrived late, got duplicated, or triggered the wrong action downstream. Track the path from the event to the response. Track the delay between publication and reaction. Track who subscribed, what executed, and where the time actually disappeared. If latency matters to your bottom line, your monitoring model has to follow the event across the whole response path rather than stopping at one tool boundary. I would also push teams towards small handlers instead of central master orchestrators. One event, one reaction, one clear owner. This doesn't mean everything has to become developer-heavy or fragmented, but it does mean each response unit stays understandable. A team can test it, replace it, and govern it without opening a massive flow just to find one hidden rule. Smaller handlers give you cleaner failure boundaries, which matters when the business needs part of the response to continue, even if another part is down. Now, on the other side, there are patterns worth challenging directly. Polling-based integration should be at the top of that list. If a system checks every 5 minutes to see whether something happened, you've already accepted avoidable delay as part of your design. That might be fine for low-value batch work, but it is not fine for time-sensitive decisions. Polling has its place when no event exists, but it shouldn't be the default operating model when event-driven patterns are available. Long-running mega flows need the same scrutiny, especially the ones carrying business logic, exception handling, and approval routing all in one file. They often look efficient because they reduce the number of assets you see, but the logic gets buried in branching and connector state. If you change one part, you are never fully sure what else you touched, and that creates a massive risk for the business. Leaders should also stop assuming that one master flow equals governance. Usually, it just creates a blind spot. People see one object and think they see control, but the actual behavior sits inside nested conditions, child flows, and external dependencies that don't show up in a governance conversation. The rule is simple. If your business logic lives inside a flow, it doesn't scale and it hides. To make that less abstract, let's move from architecture into one case where this shift becomes obvious fast: incident response. Case incident response as event-driven orchestration. Take incident response because this is where the difference shows up immediately. The goal isn't to automate a checklist. The goal is to reduce decision latency when something risky happens across multiple systems and people need to react without wasting the first few minutes. In the old setup, a security alert lands and kicks off a workflow. That workflow creates a ticket, then it sends an email, and then it posts in Teams. Maybe it waits for a human to confirm severity before the next branch runs, or maybe another flow wakes up from that update and starts its own sequence. On paper, that looks organized because each step is visible, but in practice, the response is serialized around tooling instead of the incident itself. The moment this breaks is when the incident needs more than one thing at once. Security wants enrichment, service management wants a ticket, and the team wants a channel post. The workflow keeps deciding who gets to move first, so everything starts stacking behind everything else. While the system is technically running, the business is still waiting for clarity. What typically happens is even worse. Notifications duplicate because different flows respond to slightly different triggers, and retries fire because one downstream system is slow. People get 2 or 3 messages with different levels of context. The ticket exists, but the channel post doesn't include the same state. The analyst checks one place while the manager checks another, and nobody is fully sure which step already ran. That isn't just messy. It stretches the time to triage during the exact window where the team needs signal, not noise. Now switch the design. Instead of one alert starting one long process, publish one business event. Incident detected. That event becomes the source moment. From there, multiple subscribers react at the same time. The ticketing handler opens the incident record, the collaboration handler posts to teams with the same incident ID, and an enrichment handler pulls supporting signals. Same event, parallel response, clear responsibilities. That shift changes the operating picture immediately because the business logic no longer sits inside one central flow trying to do everything. Each handler owns one job. If enrichment slows down, ticket creation still happens. If Teams posting fails, classification can still continue. If escalation rules change, you update the escalation subscriber without reopening the whole response design. The system gets easier to evolve because each reaction maps to a clear responsibility instead of being buried in one sequence. Dataverse business events and custom APIs fit well here because the event can represent a confirmed moment rather than a half-finished process. Because business events fire after successful completion, the downstream subscribers react to something that actually happened. That matters in incident response, where false starts and duplicate states are expensive. The outcome leaders should care about is not whether one flow run succeeded. It's whether triage started faster and with less confusion. You should measure P95 response time from incident creation to the first meaningful action. Measure the queue delay between event publication and each subscriber response. Measure the human-in-the-loop wait where approval or analyst review still matters. Then watch your MTTR, because if the first minutes get cleaner, the full response usually gets shorter too. This is why the case matters beyond security. Incident response just makes the flaw obvious. The same design standard applies anywhere latency matters and several systems need the same signal. Stop routing work through one giant path and start reacting to a shared business moment. Once a leadership team sees that clearly, the question becomes practical. How do you start making this shift without tearing apart everything you already have? How to start the shift without breaking everything? You don't need a total rewrite. You need a better starting point. Most organizations have too much running to stop and redesign everything at once, and trying to replace every system usually creates more risk than actual progress. Start with one specific decision path where latency is hurting the business. Pick a process where time actually changes the outcome, like incident escalation, payment confirmation, or service disruption. Don't go for the easiest flow. Go for the one where a delay creates real cost, confusion, or exposure for the company. Then you have to map the current chain honestly. Forget the pretty version in the design doc and look at the real one. You need to see which flow triggers first, which child flow gets called, and which connector is writing back into another system. Look for where the retries happen, where the humans are waiting, and where those duplicate notifications keep showing up. You aren't auditing automation volume here. You are finding the hidden business logic that runs the show. Once you can see that path clearly, define the moments inside it. Don't define them by team or by tool. Define them by the state change. Ask yourself what happened that other systems actually need to know about. That is where your event taxonomy starts. Keep the names plain and stable so they describe the business moment rather than the technical implementation detail behind it. After that, break one large workflow into a smaller pattern. Publish the event. Then you can create a few focused reactions around it. One reaction handles the system update, another handles the collaboration, and a third handles the escalation. Keep each one narrow enough that a single team can own it without needing to read the entire estate just to understand what it does. This is also where policy starts to matter. If every new requirement still gets solved by dropping more cross-system logic into one flow, your architecture will never change. Set a firm design rule right now. No new orchestration can centralize multi-system business logic in a single long-running flow. Local actions are fine, but cross-domain response logic is out. If you already have too much legacy logic to cut cleanly, use strangler thinking. Let the old and new models coexist for a while. Introduce events at the edge of one path and move one responsibility at a time. You should only retire the old chain once the newer reactions are stable and visible. It is slower than a big reset, but it is how you reduce risk while still changing the standard. Business doesn't move in ordered steps. It moves through moments that need a fast, clear reaction. That is exactly why workflow-centric automation is starting to fail under modern pressure. Pick one process this quarter where latency matters. redesign it around business events instead of one master flow, and then watch what changes in ownership, speed, and clarity. If you want more on building systems that react instead of just execute, subscribe to M365 FM. And if this changed how you think, leave a review, then connect with me, Mirko Peters, on LinkedIn, and send me the workflow pattern slowing your business down most.